Hello, this is Faran from the Republic 2.0, and today we are going to talk about the exam techniques related to all of the Edexcel specifications, especially the 9 PHOs ones and the WPH IAL Edexcel ones. So first of all, I've compiled all these thingies from the examiner past reports, and the three things we need to work on is the vocab upgrade, the mark scheme, how we can decode the mark scheme. Marking scheme means how we're going to answer a 1 marker, a 2 marker, a 3 marker, a 4 marker, a 5 marker, and a 6 marker. And apart from that, the biggest marks loser, the 6 marker questions in Edexcel specifications, whether you're talking about the 8 PHOs, 9 PHOs, or IAL ones, you know, this is a question which brings a A student down to C or a D method. So talking about these three main things, first of all, we need to just talk about a few important points from the examiner reports. The first of all is the examiner often refers that candidates often give generic textbook answers without applying physics in the scenario. So for example, whatever you're writing, if your writing got no physics principle, you know, it is going to be very generic. So you're not hitting the bullseye in such part of the problem. For example, if you've got some question on an upthrust or a terminal or a terminal velocity, and you haven't referred that a terminal velocity is only possible when the upthrust plus drag is equal to the weight, you know, that answer would have less weight. Then the scientific vocab. I've given some examples later on in the same slides that if you're not using the scientific vocab, if you're just writing it like a layman, you wouldn't be scoring high in such papers. Working was unclear or missing. You're not doing the substitution. You're not writing the formula down. You're just pasting the answer straight away by just working it out in the calculator is going to be awarded less as well. Apart from that, significant figures is inconsistent. For example, in some question about resistivity, you've been given that the area of something was 0.45 meters squares. But at the end of the day, when you're calculating the length and you're getting us length about 0.6, so they do not have consistent significant figures. So make sure that whenever you're answering it, they must have some sort of significant figures, right? Now, this point, extended logical structure. Answers were just list of facts, not the coherent arguments. So basically, this point often refers that student, whenever they're writing a 6 marker theoretical problem, whenever they're writing a 4 marker theoretical problem, they just try to list down the facts. Rather than that, they do not understand how to write a proper argumentative paragraph, as you guys might have been doing in your English essays. So you need to understand that how can you write coherent arguments in the scientific vocab, right?
Yes, and
Okay.
sir,
Yes, yes.
my camera isn't working, so I can't open it.
Okay, that's fine. Nobody's opening over here. They're all shy. Okay, so you've got 6 markers, right? Extended responses lacked logical structure, right? Answer were list of the facts, not coherent arguments. This was the point Jason was mentioning, right? You, you're not giving any sort of a logical structure. For example, many of you, that's the main reason behind the 6 marker failure. There is a question, it talks about the causes and effects, right? Now, do you guys think that somebody, if somebody is writing effects before the causes, would he get the marks? Not really, right? You need to talk about your answer in a very precise order or a logical structure. Your causes must be at first, and then you must be writing down the effects of that certain strict, right? And then thirdly, we've got some common misconceptions persist year on year, particularly around Newton's third law. For example, many of you consider the weight and normal reaction to be Newton's third law pair, and that is not the case, right? Whenever you guys are talking about energy conservation, you often forget about friction, which is equals to mu r if an object is, flowing down a slope or something like that. So these are some sort of a basic mistakes that examiners every year report back, right? So we need to work on them. And the first topic that we're going to talk about is the vocab upgrade, right? Vocab upgrade is, I've given here some examples over here. First of all, remember, whoever is checking your paper is somehow a physicist, right? He might have done some bachelor's or master's in physics. So they are just going to reward physics language, right? If you're talking about a certain structure, if you're talking about a certain structure and that looks like a very layman language, you're not going to get some marks about it, right? So for example, if you're writing, it pushes the object. How would the examiner, how examiner wants to look the same phrase? He wants to, just talk about the resultant force acts on the object, right? Instead of writing this phrase, if you're going to use this one, examiner is going to reward you. It moves faster, it accelerates, or the acceleration increases, heat is made, thermal energy is dissipated. Rather than writing this statement, write this one out. Then energy is lost. Energy should be transferred to surroundings as heat or sound. Light bends, light can refract as well. So in this block, if you guys just look into it, you can see how physics vocab is being implemented over here. Atoms move more, but we can write the same thing as lattice ion vibrate with greater amplitudes. Current flow through what? You need to talk about some sort of a component. It bounces back, very layman. The wave undergoes reflection or the total internal reflection happens. So whenever you guys are talking about an answer in your physics paper, you need to be very much specific and you need to be using the language of physics, right? Not a random language as if you're trying to make a certain topic understand a question, understand a friend. Now, we've got the marks decoder, right? Just a second. Okay. So after that, we've got some sort of a marks decoder, right? And whenever you guys are talking about the marks decoder, what we have got, we can have a 1 marker question, we can have a 2 marker, we can have a 3 marker, we can have a 4 marker, we can have a 5 to 6 marker, right? Now, this is very important. If you have got a 1 marker question, you're supposed to be writing some sort of a single fact. If it is some sort of a theoretical question, yes, yep, he's asking you to state something. He's asking you to, show that time is equal to this in the projectiles. Either a single fact or a single calculation step. And most of us, can easily score 1 mark. There is nothing wrong with it, right? Because you're going to write at least something, and that something is this one. But if you've got 2 marker, what you're supposed to write, at least you give 2 distinct points, either in the bullets or in the paragraph. I'm telling you guys again, if you're writing a paragraph, you need to use proper connectors. Consider something, you need to write it something like however, whoever, blah, blah, blah. You need to use proper connectors when you're writing a paragraph. But still, in paragraph, you must have 2 distinct points. And how the distinct points should be, you need to, somehow talk about the method, and then you need to talk about the answer. Now, 3 markers, 4 markers, 5 markers, 6 marker. You guys mess these sort of questions a lot. If this is a 3 marker question, think like an examiner. What are you telling us? If it is a calculation related question, you guys are going to give me a 3-step calculation. Or if he's asking you about something, then 2 facts plus a linking sentence. Very important thing, right? Maybe now you guys are not able to understand that what I do mean by the 2 facts and the linking sentence, but whenever I'm going to do some questions after this thingy, you'll guys get to know that, right? So whenever there is a 3 marker question, you need to give at least 3 steps of the calculations. For example, first of all, you're going to write the formula, then you're going to show the substitution, and then thirdly, you're going to show the working. Many of you just don't even dare to write the formula. They just write the substitution and just with the help of using calculator write the final answer, and that is not a proper way to write the final answer. Got that? So whenever you're writing a 3 marker, remember you need to show the formula, you need to show the substitution, and you need to, if it is a explanatory sort of a question, make sure that you're writing facts and a linking sentence. At least 2 facts, at least a linking sentence. Now 4 markers. it is very rare a student can get a 4-marker question right. First of all, you need to write the method down. Substitution, calculation. Edexcel students, especially the Edexcel students, don't even dare to write the final unit, right? So if you're not writing a unit, you're losing marks. If you're not doing substitution, you're trying to be very much genius in the class. You're losing you're losing the marks as well, right? So make sure that whenever you're doing a 4-marker, you need to show the proper substitution. For example, somebody is asking you to calculate the kinetic energy. So write the kinetic energy formula, half mv square, show the substitution, whatever the mass is, whatever the speed is, and then get me the final answer. And then the final answer should come with some sort of a unit. Okay. Now, if we talk about a 5 to 6 marker question, this is some sort of an extended response, right? If he's asking you to explain something or deduce something or determine something, we need coherent arguments. Jason, what do we mean by coherent arguments expected?
Could it mean how you need to state the strengths and the weaknesses?
Well, that is some sort of a comparison, yeah.
Oh, so is
But
it like
coherent,
an evaluation?
uh-huh.
Is it like an evaluation of a point?
Exactly, evaluation of a point, some sort of an evaluation of a point. But what do we mean by coherency argument? Coherency in the argument?
Clarity or clearness.
Not really. Anyone else? Matlab, you're close, but still, we need to be precise about coherence arguments. Harry, what do you think about it?
They're like cause and effect. So stating the point, then seeing how physics links to that point.
Exactly. The order of physics in that question, right? I've given you guys an example that you can't really state the effects before the causes. You need to be very much in an order. First of all, talk about uh, the causes and then talk about the effects, right? Without that, if you're not talking about the physics of that certain question, you're losing marks. That is for sure. So make sure that whenever after today, everybody gets, I'm pretty sure that every one of you have done some past papers, but still working on these things and then doing one past paper again would get you guys improved a lot. So when you're writing all these questions, make sure that, you get to see the marks. Either it is a 1, 2, 3, 4, 5, 6. Okay. After these number of marks, we have got these types of questions in the paper, right? Every word somehow demands a different answer style. If he's talking about state something, state Hooke's law, state Young's modulus, state blah blah blah, it is just a one-line factual answer, and no explanation needed. But the difference is that whenever he asks you guys about definition, you guys end up just paraphrasing a definition of your own, right? For example, Hassan is sitting in an exam and somebody's asking him about the Young's modulus. Hassan would come up with his own definition, right? And we really don't need that. We need a standard textbook definition. Got that? Don't paraphrase. This is the important thing. Whenever he's asking you to define something, do not paraphrase. Write as if you're just copying it from your textbook. Then if you've got some sort of a calculation related question, if you talk about the calculation related question, it can be of a 2, 3, or a 4-marker question even. These questions, whether you talk about state or define, maximum they got you 2 marks, right? Or a 1 mark for a definition as well. But when he's talking about the calculation, remember, you guys need to show the working, final answer, and unit. These are the compulsions. By working, what do I mean? I mean substitution of the values. If you're not substituting the values, you're just messing up, right? If you're just using a formula straight away, you guys got some, good calculators, and you just are showing me the final answer, it wouldn't help you to get 4 or 3 or 2 marks. Now, important question where student mess up, this one, show that something or time of this projectile is equal to 0.6 seconds, right? Now, what do you guys often do? You reach the target with full working. And what do we mean by the full working? Working, meaning thereby substitution. You need to show the substitution, but some of you guys are very smart and they just write the exact target answer, right? For example, the examiner has given you, show that the time for this projectile to reach a certain certain target is 0.9 seconds, right? And we've got some genius people who often even get 0.9 seconds as well, right? So make sure that you do not never get to write an exact target. It could be 0.89, it could be 0.92, right? So close to that target. Rather, if he's asked you guys to show that time is about 0.9 seconds, about, right? About means that we need to get an approximate answer. Determination is some sort of a same question with the calculation, but for example, you need to determine viscosity of a liquid. And in the similar sort of a question, the examiner is asking you guys to calculate the viscosity of the liquid. And I'm pretty sure all of you guys are going to do the same working for the calculation, for the determination as well. But remember that whenever he's asking you guys to determine something, you need to use the principal equation or the principle being used for that question. Every equation got some sort of a principle. If you're talking about the viscosity, the basic principle is that, the upthrust plus the drag should be equal to the weight, or the drag should be equal to 6 pi eta RVT. So you guys need to mention that according to Stokes' law, right? According to the condition of an equilibrium, if you're not mentioning that principle, you're not doing this sort of a question, right? So determine, show that, calculation, define, state, all of these words demands different answer style. When you talk about explain, everybody is good with the explanation, they can write effect, but very few people give the reason for the explanation because he had not explicitly asked you guys the because in the question. So remember that when you're writing an explain question, it could be a 4 marker, it could be a 5 marker, sometimes it could be even a 6 marker as well, right? So whenever you guys are writing this sort of a question, remember to add the because, right? The reason, the sort of a reason behind that. Got it? Similarly, whenever you've got the description, in the description, remember sequence of events is very necessary. You do not need to give me a reason, but sequence of events in proper physics way, right? Something is happening at the first order, second order, third order, fourth order, fifth order, seventh order, blah, blah, blah. You need to be ordered with your structure when you're describing something, right? Now, whenever you're talking about the deduction, remember that if you're deducing something, you'll do all the calculation to deduce the Stokes' law is being followed, right? But at the end of the day, you guys do not draw the conclusion. You do not often even state it as well, that whether with all your reasoning, Stokes' law is being followed or not. So when the question is about deduction and you guys are not giving me any sort of a conclusion and you're not stating that conclusion, again, you're messing up, right? So conclusion is important when the question is about the deduction. Whenever you talk about the compare sort of a thing, both similarities and differences, remember that whenever you've got the comparison, in the comparison, we need to use similarities and differences. Comparison never mean that we are just supposed to write down the similarities, or it never mean we are just supposed to be writing differences. We need to do that, right? We need to write both the similarities and the differences. And apart from that, in this comparison question, in this explanation one, we need to use proper connectors, right? We need to use proper connectors. At the end of the day, we've got some question related to discussion. And whenever he's asking you to discuss something, you need to make sure that you're telling him the multiple viewpoints with evaluation. Vashma, what do we mean by, evaluation? For example, if you're evaluating a point, what do we basically mean by that? Do we have Vashma with us?
Yeah. It's
Yeah.
basically like, you're stating basically you're saying whether it's like the premises are like true or it's like provides enough logic to support like your conclusion and stuff.
Exactly. So whenever you're supposed to discuss something, right? Remember that you're not discussing something with your friend. You're discussing something with your examiner, right? So you need to evaluate all the viewpoints of that certain topic. Got that? So this slide is very important. Whatever the command has been given in your Edexcel paper, you guys need to make sure you're following the command, right? Okay. Now, after that, what we have got, for example, whenever there is a question, show that time is something like that, blah, blah, blah. Now, remember one simple thing. There are a few steps. Examiners have often cotted that down. And these are that what you are supposed to do, right? We need to write an equation in a simple form. Kinetic energy equals to half mv square. You need to write that down, no matter how awkward you're gonna feel. Drag force is equal to 6 pi eta rvt. You need to write that down in proper symbols, right? Young modulus is equal to F times L upon A times extension. You need to write that down. Then you need to show the substitution as well, right? That you're going to plug in the different value for the force, length, area, extension, blah, blah, blah. Then calculation as well. Write your answer to more significant figures than the target and compare the target with, right? Make sure that you've got your answer. It is preferred. Examiners have mentioned that for the show that question, you can write your answer in more significant figures than the target. If the target is 0.9, give your answer like 0.891, because nobody, we are expecting nobody to get themselves the exact answer, right? So whenever you're doing this sort of a question, show that time is something, show that with all these calculation, eta comes out to be 9.5 or something like that. We need to follow all these steps. After that,
Teacher,
Gigi?
quick question. When it comes to writing the answer, can you leave it in fractions?
Not really. This is not integration or maths. We need to get them the decimals and significant figures. Unless or until, he wants you to get an answer in a fractional form.
Oh, okay. Thank you very much.
Okay, now we've got this sort of a thingy. A C-Earl method for 6 mark extended writing. The biggest mark loser, right? Now, how do we structure our question, right? We've got the Searle method, C for context. Just means, what do we mean by the context whenever a 6 marker question is given?
Would this be like the scenario that you're applying to the physics too? So if we're talking about projectile motion, you're trying to see what you're going to use and why you're going to use it in that scenario.
For example, we've got some sort of a question that we need to show that a boy is jumping on a trampoline, right? A boy is jumping on a trampoline, and we need to talk about that what sort of energy changes are taking place for that boy. This is some sort of a question. Have you all got that? That the boy is jumping on the trampoline, and we just need to talk about the energies, how the energy is going to change. So first of all, how would you start writing that question down? What is the context in this sort of a question, Jasmeet?
Can you say that again?
I'm just talking about that. For example, you've got a question that a boy is jumping on a trampoline, right?
Yeah.
And we need to talk about that. What sort of energy changes are going to take place? So what sort of a scenario you're gonna build over here? If the examiner is asking you to talk about the changes in the energy of the boy jumping on a trampoline,
You could state the energies that are present. So like kinetic energy for the boy that's jumping. There's GPE when he's in the air.
Okay.
And there might be thermal energy that's lost to the surroundings when he jumps.
Yeah. So whenever you talk about the context, remember that the context is mainly from the question itself. You just need to explain the examiner about the question itself, right? That this is the question, and we've got a boy who's standing on a trampoline at at the currently he got some sort of a elastic potential energy because of the elasticity in the trampoline. We just need to explain the context. And then after that, for example, if I'm talking about the same sort of a question, what principle you're going to apply? E for equation. What mathematical sort of a equation we've got over here? Hassan?
Mathematical equation. Wait, what was the
Or mathematical equation or a principle? Yeah.
No, you just write down the principle, such as like half mv squared if you're talking about kinetic energy. Now you write it down to prove it.
Do you think in the case of a trampoline, we would just be talking about the kinetic energy?
No, you'd be talking
Conservation.
about elastic potential, gravitational
Momentum,
potential
right?
energy, stuff like that.
Exactly.
You just write the equations
So
down
in
for it.
that case, you know, which energies change is going to take place? We need to talk about three energies. We've got the kinetic, we've got the gravitational potential, we've got the elastic potential energy. How are you going to talk about the principle in terms of these three energies?
Talk about how some are decreasing, increasing as the scenario goes on.
For example, the boy is just standing on the trampoline right now. He didn't exert force downwards.
So
Right.
the gravitational potential energy is at its lowest.
So right now he got gravitational potential energy. There would be some sort of a decrease in gravitational potential energy, and the boy gonna get inside that loop. His elastic potential energy gonna increase, right? And with
Yeah.
the increase in the gravitational potential energy, the kinetic energy would increase as well, right? So the
Exactly.
decrease in the potential energy is equal to the increase in the EPE, and then
Yeah.
decrease in the EPE is equal to the increase in the KE.
Yeah, you talk about how
So
it changes.
exactly. So we just need to talk about the principle. Got that? So that is the basic principle we're going to talk about here. Then after that, I've already explained that how we're going to apply that principle over here, right? So the third step would always be application of that certain thingy. Got that? And next, we need to give him a reason. After application of that principle, we need to give him a reason. And remember that whenever you talk about the reason, we need to talk about the causes and effects chain step by step. What do we mean by the causes and effects in this sort of a question, Harry? If a boy is just jumping on a trampoline and you have a question like that.
Like how the physics actually links into what's actually happening to the boy, like his motion
Exactly.
and stuff like that.
So we just need to explain the physics of that process, right? With proper causes and effects. Then at the end of the day, conclusion. This is the point where often students mess up. They do not talk about the linkage between their reason and between their context. That makes you, or that gives you guys a conclusion. If your answer do not have a conclusion, you're straight on missing 1 mark over here, right? So we need to be that much concerned with all these steps. So one is this one, the SIR, and there is another method, and this is somehow known as a peel plus. Both these methods are mentioned in the examiner reports. Okay, so we've got the SIR, and then we've got the peel plus method. So remember, for the peel plus method, and this is for sort of a question which are mostly theoretical, right? For example, I've got something like P for principle. First of all, whatever question it is, I need to talk about the principle. Then secondly, I've got some sort of an equation or a mathematical explanation of that sort of a thing. Then I need to apply only. And then at the end of the day, I need to link to the question. And after linking into the question, we can also do some sort of a comparison. So there are 2 types of 6-marker questions. Some of them can be handled by just SIR method. Some of them can be handled with the peel plus method, right? I can understand, you guys wouldn't be understanding these 2 methods quite clearly, but still when you're going to practice a question after tonight, you need to be following these ones and you'll see the improvement after looking at the marking schemes. Okay, so we've got the SIR, we've got the peel plus, maybe we've got some sort of an example now. Okay, for example, we've got this one. It don't look like a 6-marker, but still. We've got a weather balloon released from the ground. It accelerates upwards, then reaches maximum height. Explain how and why the velocity changes from release to a maximum height. Can all of you guys just, write the bullet points of this question in the chat box?